Hello, welcome back to our tutorial, and this time round I'm going to go through a work example dealing with our cylinder. Okay, so in this example we have a cylindrical container of height 25 cm and radius 8 cm containing a water to a depth of 12 cm. Find or calculate the volume of the water. Okay, so water is only filled up at a height of 12 cm. So the volume of water is basically obtained by taking by using the formula for volume of cylinder. And volume of cylinder is given by half times by base area times by height. Okay, so in this case, half is just a constant. The base area of a cylinder is a circle. So area of a circle is pi r square multiplied by height. Okay, so substituting the values, half times by pi, the radius in this case is 8, so it's 8 squared multiplied by height. Height of water is only up to 12 cm. So instead of 25, put up to 12 cm. Okay, so now using our calculator, we will get 1206.37158. Okay, so it's a long number, so we need to put it to three significant figures. It will be 1210 cubic centimeters. Okay, put to three significant figures. Right? Okay, so this is part A. Part B, solid metal cubes of length 3 centimeters are fully submerged in the water. Find the maximum number of metal cubes that can be submerged in the water so that the water will not overflow out of this cylindrical container. Okay, so basically, the balance volume of the container needs to be filled up with metal cubes. Okay, so let's look at the next part, part B here. So for part B, we need to find out the volume of the volume of the container which is unoccupied. Okay, so volume that is unoccupied is equals to half times by pi r square again, pi r square times by height. So it will be half times by pi, the radius is still 8 square here, times by balance height is 25 minus 12, right? So let me just put it here, 25 minus 12, which is actually 13. Okay, so calculating this, half times by pi, which is 64 here, times by 13. So using our calculator, what we will get is equals to 1306.9025. Okay, so this is the volume that is unoccupied. So to find the maximum number of metal cubes that can be submerged, we need to find the volume of 1 cube first. Okay, so volume of 1 cube. So volume of cube is just length times breadth times by height. So it's 3 times 3 times by 3 equals to 27 cubic centimeters. So the maximum number of cubes will be, okay, maximum number of cubes is basically 1306.9025 divided by the volume of 1 cube. Okay, so 1306.9025 divided by 27 equals to 48.404. Okay, so in this case, the maximum number cannot be a decimal number. It has to be an integer. So in this case, it will be equals to 48 only. Okay, you cannot round off to 49, or you cannot do any other numbers in this case. So that's it. That is how we deal with this question involving cylinders. Okay, volume of water. Let me just recap this question. The volume of water is basically finding the volume of cylinder because it follows the shape of the cylinder, and volume of cylinder is given by half times by pi r square height. We don't take the height of the cylinder, but instead we take the height of the water level, which is only 12 cm. Okay, and then metal cubes, solid metal cubes of length 3 cm are fully submerged in the water. How many what's the maximum number of metal cubes that can be submerged in the water so that the water will not overflow. So we need to find the volume of water, volume of container that is not occupied, okay, not occupied, which is equals to 1306.9025, and then finding the volume of 1 cube, which is 27 cubic centimeters. So if you put 2 cubes, it's just 27 times by 2, right? So logically, to find the maximum number of cubes, we just take the volume of the unoccupied cylinder, divide by volume of 1 cube, and then we get our answer. We cannot run off to 49 because technically, if you were to put in 48.404 of the cubes, you will fill up to the brim, okay? But we are not considering that situation. We're just finding the number of solid cubes. So we have to round down to 48, such that it will not allow water to flow out of this cylinder. Okay? Anything more than 48, water will flow out. Anything less than 48, 47, there is still room for one more metal cube. That's why we need to round off to 48 only. All right? So that's it. This is another example involving cylinder. Okay? Catch you at our next video.